Now I am going to perform that inventor. Here we will try to understand about that basic constraint. So go through that new file, part file, IPT, that means inventor part file. Here you can see that 2D sketch. Select that XY plane. This is the XY plane is the front plane. Now I discuss about that different constraint. In previous video we try to understand about the horizontal, vertical, parallel, perpendicular, concentric. Now here collinear. Now what it mean by the collinear? Suppose I want to draw that line zigzag form here. Here you can see that uneven horizontal line. I want to that line should be collinear. Here you can see this line having a step of this. Now I want to that apply that dimension for fix that geometry. Now I want to that this line and this line should be the collinear. So first you have to select that control and select both, and here you can apply collinear. This will be the collinear with respect to this. Once you can change this dimension, automatically it will be the change this geometry with respect to that dimension, because here we we already apply this collinear. So this is the collinear. Now if you want to that, suppose to that me symmetric, that means that here you can apply the same dimension. Here also that equal. To equal, that means that the dimension should be the equal. Suppose here I apply that dimension is point 0.2, point 0.2 each. So here this all edges should be the point 0.2. So here you can select that dimension and put it into equal. So this should be the point 0.2 each. Here you can see. Once you can change this dimension, it will automatically change due to effect of that equal constraint, because here I already applied that equal constraint. So that means you can, your geometry should be that dimension of all the entities should be the repeatedly. So there is not need to put the each and every dimension to perform that geometry fully defined. So these are the constraints you can apply anytime. Equal, that means here I want to that draw the any geometry. Suppose I make that geometry. This will be the symmetric. So here you can apply. It will be the symmetric. So with respect to that symmetric, that means here you can apply the line with respect to that particular symmetric, that line with respect to this and this. It should be the symmetric. So this is all about that constraint. Also, if you want to that lock that geometry, so here you can draw the any kind of that uh, figure or geometry. Any one of edge you want to the fix. So here it is the disturb due to that not apply that fixed constraint. So here you can see this sketch should be disturbed, but here you can select that edge, apply the lock. So this lock will be applied. Now it will be the rigid, and the geometry should be the change according to that fixed line. So there is no need to worry about that edge should be the apply the dimension or another constraint. So this is about that uh, lock constraint. So this is all about that constraint. Now I start that line command. The line should be the create by putting that start point and end point, because line is the nothing but the number of component, number of point connected to each other. So here you can start point, then end point. It should be the continuous. When you can apply the geometry by using that mouse, you can draw the continuous line. If you want to the end that command, to here you can escape or enter command. So it should be the close. So now this is the line command. Now if you in line, there are the so many different options are available. You can draw the spline. This should be the spline should be the control due to that vertex, because these are the geometry you can define by the surface modeling. There is a interpolation curve. You know about the number of order, second order, first order curve. You can control that control point on that particular point, and you can manage it. So here you can apply that spline. So you can put that outer side of that curve, it control point. Here you can see this is the control point. Here further I draw it, first point, second point, third point, and enter. So here these are the control point. According to that movement of this control point, the geometry of that curve should be the change. So this is basically used for that define the polynomial curve, and it should be the uh, arrange that particular profile or surface according to that control point. So this is the most important for the surface modeling. Now I am going to define that spline. It is already inside. This is the outside. This is the inside control point on that particular curve. So this control point should be the managed by that itself, that curve point with respect to their direction. Here you can see there is a put that click here to here you get that direction. You can change according to that movement of that by applying the cursor movement, and you can change. If you want to that make your own signature, and you can uh, whatever that artwork you want to that some complex geometry by using that spline curve, you can use for that surface modeling. So this is about that spline curve. Now circle. Circle is basically used for to draw the any shaft or any circular geometry. To here the center point circle. To here you can click the center point and drag that cursor. So you can apply that dimension diameter. Here I draw that point 3 diameter, inch circle diameter. So you can simple draw the center point and drag that direction, and you can save that particular geometry. Now another is the tangent circle. Tangent circle, that means here you want to require the line as a reference. Here I draw that random line here, another line I draw here, and further I take another line here. So in circle tangent circle, that means it will take the reference of this line of these two line tangent point and automatically bound that area, because this three line is the boundary of that particular quadrant point, and according to that tangent point it directly pick that reference point, and you can manage your circle. So here you can justify the tangent circle. Now another method to draw that circle is here. There are the two type of method already you can show that center point circle and tangent. Ellipse should be defined by using the major axis and minor axis. So here you can pick that ellipse. You can first apply that center point, then this is the major axis and this is the minor axis. If you have a dimension of that major and minor axis, so you can make the perfect ellipse, because major axis and minor axis defined that ellipse by using the focal point. Without focal point, that particular shape you can't achieve that shape, because it is perfectly aware about that shape. Now I am going to see show you arc. Arc, there are the three options to draw that or represent that arc: 3-point arc, tangent arc, and center arc. 3-point arc, that means that you having a such line. This line is here and another line here. So I want to that draw that arc between that two endpoint of that line. So I go through that 3-point arc. First I select that first endpoint of that arc, second endpoint arc, and here you can justify that center point of arc. So here this should be the fillet or similar kind. Here you can apply that tangent constant. So here you can apply it. So geometry should be the perfectly aligned with that arc, should be the tangent that particular line. So you can make a perfect geometry with respect to that area. So this is about that arc, 3-point arc. Tangent arc. If you want to that draw the tangent arc, you have a some reference line. If this is the reference line, I select that arc, select that endpoint and drag that arc. So it should be perfectly tangent point. Pick that tangent point and draw that arc. So this should be the perfectly tangent arc. Clear? So that way you can perform or draw that tangent arc. Now I'm going to show you center point arc. Center point arc is the similar. You are using that at drafting level. You are using that rounder. Rounder having a center point. This point as a center point. You can make some radius by taking the steel rule, and you can make the start point and end point. So similar kind of exercise you can perform here, and you can feel that such like a center. Here you can put that center, and here you can apply the start point and end point. So that way you can justify that center point arc, and you can understand about that how to perform that center point arc. So are you understand about that 3-point arc, tangent arc, and center point arc? Now I am going to show you rectangle. There are the different way you can represent that rectangle. Uh, Here that there are the three way or four way you can understand about 2-point rectangle, 3-point rectangle, 2-point center rectangle, 3-point center rectangle. Here 2-point rectangle, that means first point should be the one of the corner of that rectangle, and diagonally it will be performed that rectangle. Here you can see 2-point rectangle. First point is the one of the corner of that rectangle, and second point is the another corner of that rectangle. So it is diagonally it will be performed that rectangle. So this is the 2-point rectangle. Same way, if you want to draw that 3-point, that means the first two one and two second number point is the define that length, and third number point is define that width or height. So here you can try to understand about that. This is the first point, second point. So this is the defined of length of that rectangle, and this is the third point. So by using that first and second point, it identifies the length of that rectangle, and third point will be the define that height or width of that rectangle. If you want to that rectangle as such an angle, so you can go for that kind of that rectangle, 3-point rectangle. 2-point center rectangle, that means here in 2-point rectangle, it took that end point of this diagonal point in center rectangle. Here you can apply the center, and you can drag that automatically it defined that length and width, and it draw. So here you can see what is the difference between that rectangle, 2 point rectangle, and center rectangle. So here only the starting point is the center, and in here the starting point is the corner. So that is the difference between that corner rectangle and 2 point center rectangle. Now similar you want to that draw that 3 point center rectangle. In 3 point center rectangle, same, it pick that center as the starting point, and once you have to apply that particular angle, and you can drag to automatically it draw that the midpoint line and directly draw that width. So there are the four way you can represent that rectangle, either you horizontally, vertically, or you can draw it in such an angle. So that way you can define that. So this is the way you can identify your geometry in rectangular form. Basically, in mechanical, there were some machining component are there. It should be that in rectangular form. Now, I am going to discuss about that slot, how to draw that slot. There are the different way you can represent that slot. So here you can see there are the center to center. That means this is the first point, this is the second point, and once you can drag, it will be the draw that. So first and second point is the took that center of that slot, and after you can drag, it automatically draw that diameter, and you can apply that dimension what you want, and also you can apply that center point. So same way you can define that slot. Here you can draw that center point slot. So here it takes that center line, midpoint of that center line, and identify that to end position and drag it to, it will should be to that slot. So here what is the difference between that two slot represented center to center and center point rectangle. That means here it take that end position of that two center, and here the mid position of that end center, and it perform that slot. Now overall slot, that means you can draw that line, and you can outer to outer, it took that outer to outer distance. That means once you can apply the dimension, it automatically take that outer to outer dimension, and you can perform that. Any reference you can change here. Here we took that center to center, and here we take that quadrant to quadrant point of that slot, and you can perform that rectangle or slot. Okay. Now if you want to that draw that arc, suppose there is a flange. If you want to that in draw that PCD, and that PCD having a not a hole but arc slot. So here how to perform that arc slot? So here there are the 3 point arc. Same way you have to draw that simple 3 point arc, first point, second point, and third point, and then drag it. So you can perform that 3 point arc. Same way you can draw that center point arc, center point, start point, end point, and drag it. So that way you can perform that slot, center point. Polygon, that means there is a number of edges you can perform, and you can draw this, and you can do. Here I identify that number of edges is 6. So it draw the hexagon. So that way you can identify that particular. So here the overview of that, how to create a different sketch according to that.